leaving class the other day, we were working on this problem right here. This is 27 on your assignment. So everybody, pull out 27. I'm not going to do any problem twice. So if you're going to do this and follow along. You remember, I started doing it. It was getting really long. I probably didn't do it the best way. I pulled it out this morning thinking I was going to take a long time in my prep hour working on this one to try and get it. It took me about 2 minutes. It's not as bad as I thought. I just started off the wrong way. By the way, when you guys start these things, sometimes you might start on one and you take you down a trail that's not working very well. Go back and see if there's another way you can start it, okay? If you remember right, the other day when I started this one, we started off with the right side, and we're still going to work with the right side. And I'm going to rewrite it right here because that's not a very good way to write it. But when we started off the other day, remember I started off getting common denominators? Do you remember that? There's a better way. What do you think another way is we can start off on this problem? Say that again. Not with a Pythagorean theorem because there's no squareds. It's not squared, so yeah, we couldn't do that. Say that again. Yes, to what? That's what I did, and it came out a lot nicer. So let's start right there. He said change this tangent to sine over cosine, and that cotangent to cosine over sine. You guys, it never hurts to try something. Just find something and try it. So we're going to go cosine of x, and this is going to be 1 minus sine over cosine. And over on the other fraction, we're going to have sine of x over 1 minus cosine over sine. Okay, that's a good place to start. This morning I decided I'm going to start differently because the other way we were doing it wasn't working. So that's what I started off as. Okay, what can we do next? What does that help us do? Someone said it. What is that suggesting we might be able to do right here? Not times by anything. How about add 1 and sine over cosine, or subtract sine over cosine from 1? To do that, what do I have to have? I have to have a common denominator, right? I've got to change 1 to what? Cosine over cosine. Cosine over cosine is 1, and that would give me common denominators of cosine. Do you see that? Over here, what would I do with this 1? Sine over sine, right? So that's what we're going to do next. So we have cosine of x over cosine of x over cosine of x minus sine of x over cosine of x plus sine of x over sine of x minus cosine of x over sine of x. You guys see what we did? Changed this 1 cosine over cosine and this 1 to the sine over sine. And when we change this 1 to sine over sine, we have common denominator of sines. And this 1 to cosine over cosine, we have a common denominator of cosines. That allows us to do what next? Yeah, we can combine them. Well, we could, we don't change them to cotangent. That would be just going backwards. I probably want to combine these two fractions right here, this one and then this pair of fractions right here, don't I? Okay, so it's going to be cosine of x over, if this has a common denominator, I can just write cosine minus sine over cosine, right? And then on this one, I'm going to have the sine of x, right? And then I'm going to have sine minus cosine all over the sine, right? Say that again, Emma. Can't we just cancel something out? Is that what you said? We can't cancel anything out yet. You can't cancel this cosine with this cosine because this cosine is being minus. Well, what happens when you're dividing by a fraction, you guys? What do? You flip the second fraction and multiply, right? That's what we're going to do. If I flip this fraction over, if I flip this bottom fraction over, it's going to be cosine over cosine minus sine. And I times the two cosines together, and I'm going to get cosine squared over cosine x minus sine x. Can I do the same thing on the other one? Yeah, the other one's going to be sine squared over sine x minus cosine of x, right? I have a common denominator, don't I? Oh, I don't have a common denominator, do I? What's the only difference between the two denominators? Yeah, is like 2 minus 1 the same thing as 1 minus 2? It's not. One's positive 1, one's negative 1, right? So those two are not the same. You guys, to make common denominators, all I'd have to do is factor a negative 1 out of this bottom one right here. If I factor a negative 1 out of this bottom one here, when you have a fraction, it doesn't matter if the negative's in the bottom or the top or out in front. So what I'm going to do is I'm going to factor out a negative 1. It's going to change these signs. That's going to make it negative sine and a positive cosine. And I'll have a negative. I'm going to replace that with a negative. So I'm going to have cosine squared of x over cosine of x minus sine of x plus, no, I mean minus, because I'm factoring out a minus sign, sine squared of x over sine of x minus cosine of x. Oh, I was looking at the wrong one. Sorry. I switched those two around. Now it's going to be cosine of x minus sine of x, right? Because I factored out a negative 1, so it made that negative, and it changed the signs of these, so this is now a positive cosine and a minus sine, so it's the same denominator as that one. Now I have common denominators, right? So now I can combine this into one fraction. Cosine squared of x minus sine squared of x all over cosine of x minus sine of x, right? You can't cancel. You can't cancel because you have a cosine squared being minus from a sine squared. You have to do the minus before you could cancel. You can only cancel whole factors. Now, hey, you guys, how many of you remember how to factor this? What is x squared minus 4 factored to be? Yeah, it's a difference of two squares, isn't it? The square root of x squared is x, square root of 4 is 2, and that's a minus sign, so it factors like Sydney said, x minus 2x plus 2. Well, guess what? That's a difference of two squares. What is it going to factor to be, you guys? Say that again, Sydney. I didn't hear. What'd you say? That's right. Cosine of x minus sine of x times cosine of x plus sine of x all over cosine of x times, or minus sine of x. Now, remember how I say you can cancel out whole factors? So I can't cancel this cosine with this cosine, or this sine with this sine. But I can cancel cosine minus sine x, because it's a whole factor to itself, by this whole factor, cosine of x minus sine of x. So what am I left with? The answer. Isn't that what we started with? Isn't that what we wanted it to become? Cosine of x plus sine of x? No, you have to factor it like that. So cosine of x plus sine of x is what we have. It's written sine of x plus cosine of x here, but addition is commutative. You can switch it around. It's the same thing. Okay? You know, once you get on a roll and you guys start learning this stuff, you could actually do a problem like that in 2 or 3 minutes. You guys can do it. You're just writing the whole time. Yeah. You're just writing the whole time. Okay. Okay, what does 16 say? Someone tell me what it is. Plus cosine of x equals secant of x. Okay, so all right, I can see 2 different things that we can do to start off this, and I want you guys to give me some ideas. What do you see? Just something you see. Oh, by the way, which side's the more complicated side? Left side. So we're probably going to work the left side. And what is something you can see that we could do right now? Change the tangent to what? That's what we did last period, and it worked out. Should we do that? Okay, let's change the tangent to sine or cosine. Because if you don't know, just look for something. Look for a quotient identity you can use, a reciprocal identity. Just look for something you can use. So right here, we have 1 plus sine of x over cosine of x all over sine of x plus cosine of x. Well, what is that? By the way, does anybody have this problem already? Raise your hand if you got it. I want to see how many of you have it. Sam's got it. Anybody else? Okay, good job, Sam. Did you do it this way to start with? There's more than one way to do it. This is one way. Changing the tangent to sine over cosine. Okay. What is it suggesting we can do now, you guys? Say that again. Say that again. What do you mean split it off? You mean this one over this sine? We actually can't do that because of order of operation, you guys. Because if I could do it if I went 1 over the whole thing, the whole denominator, plus this over the whole denominator. I could do that. That's not how we did it last period, but we could try it that way. Do you guys want to try it that way? Actually, I'm thinking about it, and it'll probably be as long. I think there's a little bit better way to do it, but it would probably work. So, Justin, if you're on the test and you're taking this and you're not sure what to do next, and that's what you're thinking of, try it. That's what you do. That's how you learn, you guys, by the way. You just try things. You guys, this is like the last problem. We did something similar to this. What did we end up doing? Look, 1 plus sine over cosine of x. How about add them together? Isn't it suggesting that you're adding those together? How you know what? You can always do that. Think about doing that, because if you can do that, then you'll have a fraction divided by a fraction, and you can just take the reciprocal and cancel things out, right? But if I changed this to have common denominator so I can add them, what would it be? What would 1 change to? Yeah, cosine over cosine. Okay? What do you think? Combine them. Okay, let's combine them. What would it be? All over cosine of x, all divided by sine of x plus cosine of x. Now, you guys, where's my main fraction bar? Is it the top one or the bottom one? The bottom one, right? So could I make that a fraction by doing that? Now, what do I have? I have a fraction divided by a fraction. What do you do when you have a fraction divided by a fraction? Take the reciprocal of the bottom one and times it by the top one, right? So I'm going to get cosine of x plus sine of x all over cosine of x times 1 over cosine of x plus sine of x, right? When I took this bottom one, I switched them around because it doesn't matter which way they're written if it's addition, right? So what happens here, you guys? What cancels? Yeah. You guys, these are whole factors again, right? That's one whole factor. That's one whole factor. They cancel. What are you left with? 1 over cosine of x, which is equal to what? Which is what our goal was to start with, right? That's what we wanted to end up with. There's more than one way to do it, right? You guys, there's more than one way to do this. So if you did it differently, that's fine. Like, if we would have went with Justin's way, I'm sure it would have worked out. We would have kind of done some of the same steps, but it would have worked out. Mm-hmm. No, you guys, when I correct your tests on this one, I correct them on this one because I have to correct each one. I have to look at your work. But when I correct the tests on these, I follow your work and see if you're following logical reasoning. Yeah, if you get part of it right, I give you partial credit. I don't know yet. It's a couple weeks away. We have a guest speaker coming in next Thursday. Why? Well, I've had this guy come every year. You guys, how many of you guys know Arthur LeBaron? Yeah, he's the city engineer, actually. He's got a degree in engineering. He's also the city surveyor. And surveying takes a ton of trigonometry. And he is going to come in here and he's going to show you. He's going to bring in a survey stuff. We're going to actually, I don't know with this new school because it's not right out the back door like before, but I think we'll probably go outside and survey a little bit, show you what he does. But he shows you how much a career in surveying pays. And by the way, the computer inside the little surveyor thing does all the math for you. You need to still understand how to set it up. So you still need to know the trigonometry. You just don't have to do all the calculations. But we're going to be having what we call the TrigStar test. It's a math contest. You only have to do it if you want to. Last year, our winner was Kasdan Jolly, and he won $100. And second place was Jared Cahoon, and he won $50. And third place was a girl. I can't remember who it was. It was from Mrs. Kidd's class. Well, I remember Kasdan and Jared because they were in my pre-calc class last year. And the other girl was in Mrs. Kidd's pre-calc class. The year before, she had the first place winner, and I couldn't remember who it was. So, and she won $25. I think it was a girl. The year before, the winner was a girl. And you can win $100 taking this test, and we'll go over questions. And if you want to enter the contest, you have a chance to win some money. So, what? And Mr. LeBaron does all the grading of the tests and everything. So he does that. 18? What does 18 say? Can I just see it? Sine of theta plus cosine of theta? Hey guys, which side looks more difficult on this one? Okay. I think we're going to start with the right side. Did anybody get this one that wants to tell us how they did it? What? You got stuck? Okay. Anybody else want to? What did you do, Ammon? Just curious. Okay, well, the problem with that is this is a 2 sine squared. So if you can't put parentheses, you're kind of like putting parentheses there and making that a cosine squared. But it's very similar to that. What we're going to do, you guys, if you have 2 sine squareds, that means you have sine squared plus sine squared. So we're going to write sine squared of theta plus sine squared of theta minus 1 all over sine of theta minus cosine of theta. Do you see that? Sine squared of theta plus sine squared of theta minus 1 over sine of theta minus cosine of theta. Okay? Now we can do what you said. Ammon said that he combined these. Now the problem is sine squared of theta minus 1 is not cosine squared of theta. 1 minus the sine squared of theta is that. But Jared, you just said it. Sine squared of theta minus 1 is actually negative cosine squared of theta. But I'm going to go about it in a different way because we don't really have one of those written down. But you're right, it is. Okay, so what I'm going to do is I'm going to replace sine squared of theta with 1 minus the cosine squared of theta because that's what it is. Okay, and then this will cancel out. Does that make sense? You're right. I just don't want to skip a step for these guys. So I'm not going to use these parentheses here. Well, maybe I will. I'll just put them right here. Okay? We're going to replace that with what? No? Sine squared is 1 minus the cosine squared. By putting a negative cosine squared in, we would have been skipping a step. So I just was showing you the step. Okay. Do I need parentheses right there, you guys? Technically, I don't because I'm not multiplying it by anything, right? So this just says sine squared plus 1 minus cosine squared minus 1. If I'm combining like terms, what cancels out? The 1's. And so what am I left with? Sine squared of theta minus cosine squared of theta, right? All over sine of theta minus cosine of theta. Hey, by the way, you guys will find out the more you do these and practice them, that you'll see some of the same stuff over again. And we've seen this already today, haven't we? Sine squared of theta minus cosine squared of theta. What did we do with it? What did we do with it, Callie? Well, no, we don't need to factor out -1. This is squared and squared. I think you added a couple of ones in there, but that's a difference. That's a difference. That's a difference of 2 squares, right? Remember the x squared minus 4 I showed you? This factors into 2 perfect squares. Sine theta minus cosine of theta. I don't know if this is what you were saying, Jared, but... Oh, is that what you were saying, Dylan? I only heard you say one of them, so I didn't know. It's a difference of 2 squares, so it factors into sine minus cosine times sine plus cosine. So what cancels out now? Those cancel out, don't they? Because those are whole factors, and what am I left with? That's what I wanted, right? Right there. Okay? I'm not changing. Okay, so you've seen a couple of things over. Okay? You guys, I know some of you guys are struggling with this stuff. You got to keep plugging away with it. You'll get it. You just got to keep doing it. If I can follow what you did, I don't. Sometimes I'm not sure how you got from one step to the other. If I can't see it, then I'll mark it wrong. Yeah, I only put 5 of them on your test. 5 identities. Well, there was a, yeah, you can use a 3x5 card. Much information. Also, you know, there were some problems from the first section, 7-1, that we did. By the way, some of the identities are really simple. Like sine times cosecant equals what? Some of them are that simple. And they range from simple to complex, 5 of them. I think there was 5. That's how many I have on the test. There's also, we're going to do lesson 7-5, which is solving trig equations. That's easier than this. Okay, a little bit easier than this. I told you guys this is the hardest stuff we learned all year, didn't I? Well, it is. Okay. We've got some other stuff we're doing this year. Okay. All right. 22. What does 22 say? Cosine theta? Times what? Of negative? Oh, this one's an easy one. Hey, you guys, look in your notes. One of them, when you take the cosine of a negative or the sine of a negative, one of them ends up being negative and one of them ends up being positive. Which one ends up being, which one ends up being positive? Guys, look at cosine of negative theta. I gave you this identity. What is cosine of negative theta equal to? It's equal to cosine of theta. I gave you this one the day after. The next day after I gave you the regular Pythagorean identities. I did. And sine of theta is equal to what? Negative sine of theta. Well, guess what? That's going to change this sign out in front right here, right? Yeah, I gave you 2 identities. Cosine of negative theta equals cosine of theta. And I gave you sine of negative theta equals negative sine of theta. So if you don't have those identities, write them down real quick. Those are called the even-odd identities. Okay? Or this book calls them opposite angle identities. Some books call them even-odd identities. My old book called them that. Okay? Do you guys see what happens next on this problem? What is cosine squared plus sine squared? So you get 1 equals 1. You're done. 20? Okay. Hey, by the way, I did some problems in my other class too, and I put that video on there if you want to look on that video. You guys are going to miss out on the puzzle we're going to be doing. You guys are going to feel sad. Guess what's being implied right here? What is being implied? That you times these two together, right? Now, in my last class, I said, what else could we do? And so I'm going to ask you guys that. What else could we do besides doing that? Kyle, this is your famous answer that you keep giving and you're always right. What else could we do besides times these two together? To what? What do you mean? You knew all the other times? Sine over cosine and 1 over cosine, right? I could do that, but in this case, it probably doesn't matter which way you do it, except for it's probably faster to multiply first and then change them. Okay? Or you can change them first and then multiply them together. But you're going to have less work if you multiply them first. Yes? You could divide by the reciprocal. There is no reciprocal up here right now. Yeah, but there's not a fraction over a fraction. To do that, you wanted to have a fraction over a fraction. Or a whole number over a fraction. Or a fraction over a whole number, okay? So, but thanks, Nephi. So, right here, you guys, we're going to go sine times tangent. And sine times secant. And -1 times tangent. And -1 times secant. That's what we're going to do next. Good. Samantha said, let's change the tangent to sine over cosine. And she said, change the secant to 1 over cosine. And the tangent to sine over cosine. And the secant to 1 over cosine. Now, if you notice, if I simplify these, that's going to be sine squared of theta over cosine. This is going to be, sine times 1 is sine, so this is going to be sine over cosine. This is going to be minus sine over cosine. And that's going to be minus 1 over cosine. Why? I don't like to use the word cancel when you add things up and they add up to 0, but they do add up to 0 and they're gone, right? A lot of people use the word cancel, but they actually add up to 0. So the two middle terms add up to 0. Does everybody see that? 0. So I'm left with sine squared of theta minus 1 over, why can I write it as one fraction? Because they have common denominators. Now, this goes back to that other problem we did. So Jeff, do you see what you were asking me about now? Okay. Secant squared minus 1 is not cosine squared. What is it? It's a negative cosine squared. I could, if you guys wanted to, we could factor a -1 out of that and make it 1 minus sine squared with a -1 in front of it. But it's the same thing. So it's negative cosine squared over a cosine, which, you guys, is the same thing as negative cosine times cosine all over cosine. And these cosines will cancel out. So my answer is negative cosine, which is what it wanted us to come up with. Got it? Wait, you've been goofing around? You don't want me to erase it? I'm going to a different page. I'm going.
Go to 26.
Okay. I did 27 at the first of class. I'll tell you what. I'm going to do 21, and then 26, you guys, I did for the other class. You can go online and look. I'm going to let you have one more day. I want it done. For everybody that's done, I want you to turn it in. I want you to turn it in if you get it done. But if you don't get it done, I'll let you have till next time to get it. Okay. 21. What does 21 say? What? Cosine of what? It has a y? Cosine of y over what? 1 minus sine of y? I never did this one for the other class. Okay. Which side looks more complicated? They do look the same, don't they? They look about the same complicated. So it probably doesn't matter. What? This one is the one where you'd use the conjugate. Okay? Connor, do you need to come up here today? Okay. All right. I'm going to start with the left side. And we're going to times the top and bottom by the conjugate of the denominator. What's the conjugate of the denominator? Yep, 1 plus sine of y. What happens right here? We got to multiply, don't we? Here we go. I'm just going to leave this as cosine of y times 1 plus sine of y. And if I times these two together, it's going to be 1 minus sine squared of y. If you foiled those on the bottom together, 1 times 1 is 1. 1 times sine y is sine y. Negative sine y times 1 is negative sine y. The two middle terms would add up to 0. And negative sine y times sine y is negative sine y squared. That's what you would get. Does anybody see what we can do next? Say that again, Justin. Yeah, this bottom right here is a Pythagorean identity. It's cosine squared. One minus the sine squared of y is cosine squared. Now what can I do? Yeah, this cosine will cancel with one of those on the bottom, and you're left with 1 plus sine of y over cosine of y. And that be your answer. All right, you guys, we're going to do a puzzle right now.